Got the old Hickok 539A out and checked the tubes, and out of the 6 tubes in it, let me see here, this is the 35Z5. It was completely dead. No heater on it, heater filament. Let me see, this is the 35L6 tube. That's the one where the base was loose on it. It had a short in it, so that's no good. And this unit's supposed to have 2 of the was it 12 SQ7s. Interesting. Instead of 2 12 SQ7s, it had 2 12 SK7s in it. So I went and found I had a used of the 3.5. See if I can find the label on it. But this is the rectifier tube. It checked out really good. We're cleaning it up. Use that. Then I went through my tube stash that I have, and I have a 3.5L6 here, and then I have another 12 SQ7. So we're letting the tube tester warm up again. We're going to go ahead and test these tubes before we put them in the receiver and make sure they work. So we'll start here with let's go ahead and start with the which one was this? This is the 3.5L6. So we'll start with that. See if we can get this to focus. Okay, 3.5L6 filament voltage is set to 35. The selectors are JR5347-0. Bias is 6.5, and then we press P4. Then we set the filament to B, or the micro ohms, to B, and then the minimum's got to be 3650. So before we do that, or we'll go ahead and set those settings on the selectors up here. So it was JR53470. So we've got JR 5 3 7 JR 5347 0. Okay. And this is set to B. And set the grid bias to 6.5. Now our line voltage is set at 117. Okay. So our power it off and put the tube in. Now before we actually use this setting, we're set to BLST. I'm not sure what that stands for. Okay, and then we're going to set this to 5. And we turn it on. And we should have a light there. But we don't. Oh, yeah, that should be right. So, unfortunately, oh wait a minute. The tube I took out, that's the tube I took out. So it looks to me like that's a bad tube that I took out of the box. Well, that's not good. Go ahead and pull that one out. Put the one that came out of it back in. I've got the same thing. So I don't know if I've got two bad tubes. Or if I'm doing it wrong. So let me double check the instructions a little bit and see if I'm missing something here. Well, it turns out that 35L6 actually was bad. So we're going to move on to checking the what are we checking now? The 12SQ7. So the first thing, I've got my selectors all set right here. I've got the filament and BLST, and I've got the shorts in position 5. So according to the manual, if I turn this on, then the shorts light should show up. So we're going to go ahead, turn the power on here, and yes, we do have that. So that means the filament's heating up, which it is getting warm. Okay, so according to the roll chart, the filament should be set to 12.6. So I'll turn it over to 12.6. Or check for shorts by moving the dial here back and forth and making sure we don't have any, the shorts light doesn't light up now. So that's one. I'll let one warm up a little bit. There's a capacitor apparently in there that charges, and if I don't get a quick light there, I think we're good. So we're good on that. So we're going to move it over to the tube tests setting. So we're there. Now it says the minimum mutual conductance on this in testing this triode section here should on E should be 700. I've got my grid bias set to 0.9. So we're going to push this down here, and as long as it's above 700, we should be good. So this looks like so far it's a good tube. Now, the other thing that we can do here to test for longevity is we switch the bias range to 50 volts. And now set the bias up to where it's mutual conductance. This is kind of hard to do with one hand. Let me set this and come back. Okay, so what we do to test longevity, we'll go ahead and test this. And then what we do is we flip the this down to test, and it shouldn't change more than 20%. Oop. Not sure what I'm doing wrong here. Okay, to test longevity, we will push the P4 down, and it's well above the 700. And then what we'll do is we flip this down to test, and it's not supposed to change more than 20%, which it didn't. So the longevity on at least that section of it is in good shape. We'll move on to the next section here. Okay, I've got the tester set up to test for the first diode section of the 12SQ7. So I push P1 down. That shows me that it's okay. So we're set up for the third section, the second diode. And the third section tests that okay. Now, I skipped over it, but I did check for shorts on each section before I ran the test. So the 12SQ7, the new 12SQ7 that I have is good. We've got the dial cords restrung. They seem to work pretty good. Let's see here. Oops, wrong way. So we've got that done. Now I'll flip it over and show you what we got accomplished underneath here. First, we really couldn't save the original speaker. This is rusted in here, and short of pulling it apart and trying to redo it and recone it, just didn't make sense to try to save this. So I was able to find some replacement 3.2 ohm speakers on eBay. So we've got one of these. I'm going to have to change the mounting brackets or mounting studs on the case to make it fit, but since we're going to redo the case anyway, that shouldn't be a big issue. As you can see, we have the S-38 operating again. This is on a local broadcast station here in town. And in fact, I don't even have an antenna hooked to it, so it's doing pretty good as far as that's concerned. Since the last video, there's been a lot of changes, which I'll go over right now. I'll go ahead and turn this off and roll it over so that you can see what we did. Initially, I was planning on mounting the isolation transformer over on this side of the of the chassis, but I realized if I did that, I wouldn't be able to slide the case over the top of it, so we had to make some changes. So what we did is we mounted it down below. I had space there, drilled a couple holes in the chassis and mounted it with rivets. That forced me to move the electrolytic capacitors from that location down to the center down here, but that worked out fine. Then I went ahead and mounted mounted that there to tie the wires into. There's a safety cap there, and then we had to add a 12 UF capacitor to bring the voltage back down to about 121 volts. I used a unused solder lug there on one of the sockets and brought it back in. I also mounted a 1/2 amp slow blow fuse, so we have some pretty good protection there now. I got done doing that and everything seemed to work pretty good. I was going through the alignment, and then all of a sudden I had very low audio output. Spent a day and a half trying to figure out what that was. I finally was trying to test some voltages on the tubes. Came down, you can see that blue resistor right there. I happened to touch that and the audio came back. It didn't seem to be moving. That, I mean, it was in there solid and everything, didn't seem to be moving very much at all. But I went ahead and resoldered that connection right down there, and then everything started working okay. So I had a cold solder joint that cost me a day and a half. So I've got that done. Went through preliminary alignment on it and everything aligned pretty good except for band 4. You're supposed to set it at 30 megahertz, inject a 30 megahertz signal into it and align it for highest output. Just can't do it. I can get it to about 28 megahertz and it won't work. So I tried replacing some silver mica cap there. It helped a little bit, but didn't do anything. Finally, you see that one wire that's loose there. I took that off. That was tied into, let me find it here, that terminal right there. I went and looked, and that's not where it's supposed to be tied to. I looked at another S-38 I have waiting to get restored. There's no wire there. There's a wire wrapped around the coil there, and you can see that looks a little odd. After investigating it a little bit further, that wire is supposed to wrap around and then go back in and connect inside that coil. So that's what's preventing me from getting the band 4 to align properly. So this weekend what I'm going to have to do is I'm going to have to desolder all those, take that coil out, and see if I can fix that coil. Other than that, I think I already went through it. Oh, I got the BFO to align correctly, or to work fairly well. Other than that, the other thing I wanted to point out, I did go ahead and put a strain relief, drill that out, put a strain relief on there instead of just tying a knot in there. I removed the capacitor that went from that connected to the case to the chassis, since we have the isolation transformer where we no longer need that. There is also a capacitor that went in down there that I removed that we no longer need because of the isolation transformer. And that is about it, I believe. So we'll go ahead and put this video up and do something on replacing that coil, or fixing that oscillator coil or transformer. And finally, after I get done on that, we'll start working on the case itself. So until next time, this is KB0ASQ.